Let's have a look at the concept of half-life. Half-life comes up a lot in science, and we do a lot with it in math, but students have difficulty figuring out what it really means to have a half-life, number one. Number two, what does it really represent? What does it look like? This visual will help, I think, make sense out of half-life. What I've got here is an atom, or little model of an atom of some sort. What I'm trying to do is illustrate what happens as we look at the half-life of this, and we created a function here called half of x, and I set that equal to 10 times 1/2 x over b, where x is the number of years or cycles and b is how long it takes for a half-life. So right now b is 8, so this picture should be about half the size when you slide over to 8. So I'll slide over to 8, and you'll be able to see that it shrinks the picture of the atom right along with the curve, and it's graphed right on the curve itself. So when I press play, I can see a couple things happening. I can see the little black dot moving, and also it's attached to the nucleus, or this cell, or this atom here, and you can see that as each one moves, the atom shrinks accordingly. So anywhere you stop, you have a calculation of what the half-life, or how much is left of the atom, along with the equation. What I've got here that I'm sliding over, those are the sliders for P and B. You can also slide the half-life over, so if you wanted to extend the half-life, now it's 15. The function will recycle in a second here. But once you recycle the equation, you'll get a brand new look at this equation. The whole thing all works together. You press play, and you can watch half-life. You get an illustration. You get the actual curve itself, a moving point, and the calculation. So your slider is working in a lot of different areas here. You're sliding the black dot, which is the position at any point P. B being the half-life variable, and what the value is at any given point, and the picture itself shrinks along as you're going across the curve, so that you'll be able to see when the slider slides. Now I'm less than half of the original amount, which means my p-value is higher than my b-value because it's more than half of the leftover distance. So again, just another illustration on how you can use sliders with graphs, with pictures, with functions, all working together, and also giving you a nice visual of what's going on.